So our topic is green cloud computing, and these are our team members. And our aim is to implement green cloud computing techniques on a software as a service, and we have chosen an image processing software to do this. Talking about the user interface, let's see why we have chosen an OLED pixel first. The thing is that LCD and LED pixels consume constant energies irrespective of the color that they are producing. Therefore, an OLED pixel has its own colors and hence consumes different energies for different colors. So, assuming the energy consumed by a black OLED pixel is K, we can find the energy consumed by an OLED pixel by its RGB combination like this. And there's also a graph that are red and green consume similar amounts of energies, whereas blue consumes a lot more energy. Talking about the user interface of the energy consumed by screen. So it can be seen that a standard HTML page has a white background and we have optimized it such that it has a black background and white text. And the difference can clearly be noted. The K is the same value as we used in the last step. And we have assumed the minimum screen resolution for modern computers, and we have assumed it to be 1600 into 1900 pixels. And we have used 72 characters on our page, and each character is 24 pixels in height. And this is the energy efficiency, 85.64%, and it's also evident from the graph present over here. Talking about the efficient print design in green fonts, it is evident that Century Gothic consumes 30% less ink than Arial. So the relative font that we have chosen here is Arial, and it can be found in almost every operating system and software. So we have saved 30% ink as well, and that contributes towards green cloud computing techniques. And now we have the hotkeys. So we have implemented hotkeys for each and every operation that we can perform in our application. So we have the insert button to upload an image. We have the S button to submit an image. We have 1 to 9 buttons for selecting the OpenCV effect. And it should be noted that when the mouse is idle, the screen refresh rate is 15 Hertz. And when we are dragging the mouse around, it's 60 Hertz. So using that formula and keeping that in mind, keeping the fact in mind that only the particular area of the screen refreshes when we are using the hotkeys, we save 75% of the energy. Talking about content placement, we have ensured that all of our content is placed in a 400 into 800 pixel rectangle, and the minimum screen resolution is 1600 into 1900. So the ratio is huge over here too, and we have contributed towards effective content placement. And I'll hand this over to Prerak now to talk about thread scheduling.
Thank you, Ayush. Now, our job is to manage user threads to save energy. Our project involves display of images after being processed according to user's request. Earlier, deletion of these images were performed by removing each user's thread by accessing database with the limit of 15 minutes, as set by default, after another user's post request. But now we have implemented a daemon thread which runs in the background once in an hour to delete every user thread altogether, which has been around for more than 15 minutes. By implementing this, we have achieved efficiency for both power and time while keeping the storage same. The formula here represents how much energy is being saved. Here we can represent by calculating energy consumed using daemon thread and energy consumed by each user's request. Now, moving on to our example, we have next slide. We have 5 users who use our service per hour. Energy saved can be calculated as 1x is the energy consumed by the daemon thread and 5x is the energy consumed by 5 post requests, which is equal to 80% of energy being saved. Similarly, for 100 users, we saved about 99% of energy consumed. Instead of making 100 requests for each users, we create just one request for 100 users. Now, moving on to synchronous deployment, we have WSGI, Web Server Gateway Interface, which is a synchronous deployment. Normal coding practice involves creation of as many threads as there are users and requests were fulfilled asynchronously. We do not need to create as so many threads, hence saving power consumption. WSGI allows us to handle requests synchronously so that the thread overheads are not high in number and hence Our thread pool is short, which results in energy efficiency. The energy of thread overheads is only dependent upon the implementation by Python, Django, and the OS. Now, let me hand over to Abhay to talk about code efficiency in our project.
Thank you, Prerak. Now I'll talk about the efficient coding techniques we have used. The first thing we did was we did data compression. We compressed all the HTML, CSS, and JavaScript files that were being delivered across the network. Initially, they were taking 2.7 kilobytes, and after compression, they took only 2 kilobytes. So that's about one fourth of the energy, or 24% that's saved. We could have also done code golfing and we could have reduced the bytes a little more, but then each time whenever we had to make a change, it would be difficult. So we used the HTML, CSS, and JavaScript compressor to compress it. Moving on. We cleaned up the library. We wrote the front end only in pure HTML, CSS, and JavaScript. We did not use any framework like React, Angular, Vue, or anything else. We got rid of jQuery library, which consumed about 87 kilobytes of data. We did not use any other CSS library like Bootstrap. We used pure HTML, CSS, and JavaScript. Also, we minimized the imports in the backend. For example, instead of importing OS, we imported path from OS. So we only imported how much ever was required in the code. Moving on. We used efficient algorithms and data structures. We used NumPy array instead of using Python list. So NumPy arrays were implemented in C and C++, so they execute much faster compared to lists. We also did vectorization, which is within an iteration, you're performing a bunch of operations at the same time instead of performing them one by one. On the left side is the code in which we implemented the sepia filter using iteration, and the same thing was rewritten using vectorization on the right side. We performed this test on two images. One was a PNG image and one was a JPEG image. If you see the results without vectorization on the first image, which was a PNG image, it took roughly 4.2, 4.3 seconds to execute. And on image 2, it took more than 17 seconds to execute. But after executing with vectorization, the first image took 0.04 seconds and second image took 0.17 seconds to execute. So this is about 100th of the time, and that's more than 99% performance increase. Now I'd like to hand it over to Purvi to talk about data storage.
Thank you, Abhay. So for optimizing data storage, we changed the database from SQL to MongoDB, which stores its data in JSON style objects and has advantages like document-oriented storage, vertical, horizontal scaling of database, and throughput of queries. Moving on, for bare bones, that is when there are no records and only the schema is developed. MySQL occupies 132 KB and MongoDB occupies 176 KB. But when we start adding the records, MySQL uses 110 bytes per record, but MongoDB uses 82 bytes. So for a very large number of records, the space occupied by bare bones for each would be negligible. So the storage space saved per record is about 25% for each record. Now moving on. For calculating the throughput, we showed the results of different operations that have been applied on MongoDB and MySQL databases. Here we can also see the code snippets of a project for each operation. So for insert operation for one user, MySQL used 96 milliseconds, MongoDB 3 milliseconds. For 1000 users, MySQL used 402 milliseconds and MongoDB 33 milliseconds. For a select operation for one user, MySQL used 2 milliseconds, MongoDB 3. For 1000 users, MySQL used 28 milliseconds and MongoDB 31 milliseconds. Moving on. Similarly, for update and delete, we can see that MongoDB uses lesser time for more number of users, therefore giving higher throughput. In a project, the insertion and deletion is performed every time for each user, but the selection operation is done only once in an hour. So although more time is taken by the select operation, but the number of times insert and delete operations are performed is more. So it is overall improving the performance. Also, select operations can be optimized through indexing, which will be further explained by Nishchal. The only time when MySQL obtained an advantage was with the select operations. The other ones gave advantages to MongoDB. Moving on, SQL databases are implemented in a scale-up architecture or vertical scaling, which uses larger computers with more CPUs and more memory. NoSQL handles large volumes of data using horizontal scaling. So, if we have to scale a database by 2x, we require 2x RAM and CPU cores. In vertical scaling and in horizontal scaling, we require constant RAM and CPU cores for each machine. So now I would like to call Nishchal.
Yeah, thank you. So let's talk about the query optimization techniques we have used in our project. So basically, we have used MongoDB. So to implement the MongoDB in our project, we have used the Django library that implements the MongoDB in Django. So the query optimization we have used is creating indexes. So by creating indexes, we can improve the performance of our project significantly. Like on the right side of there's a table. There you can see that the insertion with index takes 54 milliseconds and without index it takes 35 milliseconds. So here the insertion time is more with index. But in read, you can see there is 5 milliseconds for reading with index, and without index it is 30 milliseconds. That is like 6 times. So even if the insertion time is more with index, because we are doing the indexing, but the read time decreases significantly, like it is 1/6. So as you know that insertion takes only once, but the read takes many times. If we are scaling up our project of web app, so the read operations will be very, very large. So in that case, we are optimizing it great. So on the left side, you can see the code for the indexing we have used. So basically, we have used Django library. So we have imported the indexing, and then we have made the indexing on the image time, because on the image time we have, because we on the for deleting the images, we are using the image time here only. So only to optimize the better, we have just used the image time for indexing. Now moving on. Also, these two are the pie charts of the what I explained before. So basically, as you can see, there's so much less time we are taking with index in reading 1K records compared to the this without indexing. So let's move on, and I would like to show my yeah. So these are the references. So first reference is for the UI efficiency we have used, and then we the multi-threadings, and then after that the code efficiency, and lastly the data storages, the references we have referred to. Now let me just share my screen to show you about the um, about our project live demo. So is my screen visible? Yeah.
Yes, it's
So
visible.
thank you. So this is the front end of our project. As Ayush explained, the we have used the black screen for for saving a lot of power instead of going with the white screen. And then the fonts here we have used only the Century Gothic, that are green fonts. Let's just upload an image. I'm selecting this image and using hotkeys, like here I don't have to use my mouse, and I can directly select 7, 8 or anything, and then just press S to submit, and wow, that's it. You can get the image here right after this OpenCV customizations. So let's go back, and I would like to show also our code base here. So first of all, I will take you to the settings .py of the Django, and here in the I will take you to the database. Here we are using Django database, that implements MongoDB on Django, and the database name is Green Cloud Computing DB. Now I will take you to the views.py. See, such a very small number of inputs we are making, and in the upload image we are using this vectorization, the different coding efficiency techniques explained by the Abhay. And here you can see we are making the insertion into the database, and these are different read write operations we have made using OpenCV, and different like editing of the pic. Here you can see the different options, and then I will take you to the models.py. So here, as you can see, this is the basically model without indexing. And after that, when we are importing all the indexes, here you can see the code of indexing on the image time table. So let's take you to the yeah. So lastly, I would like to end it here. So these are the code base you can see, and yeah, also the compressed and uncompressed file. I would like to show you that also. So in the HTML, this is the uncompressed file, and this is the compressed file. In like all the database, all the white spaces removed, and this is a compressed form. And same for the script.js, and here we have the script.js in the compressed form, and also the style.js. So I would like to end our presentation here, and thank you all. Thank you, sir, for giving us the opportunity for this project.
Thank
Thank
you.
you, sir.
Thank
Thank
you.
you,
Thank
sir.
you.